having is, this is equal to minus u cube raised to power 4, or let me do it this way, is equal to minus 1 raised to power 4. I'm taking this minus as minus 1 because 1 times everything here will still give us 1. So minus 1 times everything here will give us minus u cube v squared. So we now be having u, that is this minus 1 raised to power 4, u cube raised to power 4, that's times 4, then v squared raised to power 4, that would be times 4. That is, when you have, based on the fifth law, the fifth law states that a raised to power m is equal to a raised to power m times n, which is equal to a raised to power m n. That's why I'm multiplying. So we'll now be having minus 1 times minus 1 will give us plus 1. We are multiplying 4 times. And that is minus 1 times minus 1. That's plus times minus 1. That would be minus 1. Minus 1 times minus 1 will now give us plus. So we'll now be having 1 times u times this 3 times 4 is 12. That will be u times 12, u raised to power 12, v times v, that's 2 times 4 is 8. We'll now be having 1 times u times v, 1 times u raised to power 12 times v raised to power 8 will now be u raised to power 12, v raised to power 8. Now for C, we are having minus 4 u squared v everything raised to power 3. This will be equal to minus 4 raised to power 3 times u 2 times 3, that is 2 times 3. Then v times v, this v is like 1. It's just arbitrary since it is 1. V anything raised to power 1 is will still give us back the number. That will be 1 times 3. So now what we are now having here is just like this. Minus 1 times minus 1 is will give us plus 1 times minus 1. Okay, the first one is equal to 1. Now, when we now have 1 times minus 1, the third time, we now be having minus 1. So, that will be minus 4 raised to power 3. 4 times 4 is 16 times 4. Again, is 64. That will be minus 64. U raised to power 2 times 3, that will be u raised to power 6. V raised to power 3, which is our final answer for examples under the fifth law of indices. Now, we'll be going to the sixth law, which is of this format: a raised to power 1 over, let's just say, n, which is the same thing as this 1 raised to power n simply means our n is our root of a. Everything raised to power this 1. But that is being treated under the seventh law. So the question here that we are taking for, that was example 6, that's a 27 raised to power 1 over 3. That is the cube root, which is equal to 3 root 27, which is equal to 3. That is, we can just check it. That will be 3 times 3 times 3, which is 3 times 3 is 9. 9 times 3 is equal to 27. So this gives us our final answer for example 6. Example number 7 is based on the 7th law, which is of this format: x raised to power a over b. Mind you, the other one we have is just 1 over b. It's something like 1 over b. So what we'll be having here, it will be b root x, everything raised to power a. So, but treating the example that we're having here, we're having 8 all over 27, everything raised to power minus 2 over 3. We are combining different laws here. We are combining the 4th law, the 6th law, and the 7th law. This minus means everything that we have here all over 1 all over everything that we have here. So is equals to 1 all over. Let's first treat this minus. We'll now be having 8 all over 27, everything all over 2, 3. So we'll now be having something like this: 1 all over the cube root of 8 all over 27 squared, according to what we are having. So we'll now proceed. The cube root of 8 is what? 2. The cube root of 27 is 3. Everything squared. So we'll now be having something like this. That will be 1 all over 4. Well, 3 squared is 9. Now, for us to treat this one, we don't need it. It's just the same thing as 1 all over 1 divided by 4 all over 9, which is the same thing as 1 all over 1 times 9 over 4, which is equals to 9 divided by 4 is 2, 1 over 4, which is our final answer. Example number 8. For what value of y is 125 raised to the power 1 over y equals 1 all over 25? Now, from the question, we have to look for the multiples of 125 and 25. 5 is a multiple of 125, and then 25 also is a multiple of 5. So that is 5 is a multiple of 25. So this one is, if we should check the multiple of 125, that will be 5 raised to the power 3 times 1 raised to the power. Then we have something like this is equals to, this our 25 is still the same thing as 25 raised to the power minus 1. So we're having 5 raised to the power, which is also equals to 5 squared times minus. So we'll now be having 3 times 1 over y is equals to 5 raised to the power 2 times minus 1. We have 5 here, we have 5 here. That will be 3 over y is equals to 5 raised to the power minus 2. Since our terms are the same, we can just neglect them. So we now have 3 raised to the power y is equals to minus 2. We'll now be having, if we should cross multiply, we'll be having 3 times 1. This one is just like 2 minus 2 over 1. Then we'll be having minus 2 is equals to minus 2 times y. That is 3 is equals to minus 2y. Then we can conveniently say that if we should divide both sides by minus 2, we'll now be having something like this. 3 divided by 2 minus 2 is equals to minus 2 divided by minus 2y divided by minus 2. This one will cancel out, this minus will cancel this. So we're having our y is equals to minus 3 all over 2, which gives us the value of y, for which 125 raised to power 1 over y is equals to, that means, therefore we can conveniently say that 125 1 over minus 3 over 2 is equals to 1 over 25. That is our y is equals to minus 3 over 2 from what we have here. And that's just what was substituted into the question. Example number 9. If 3 raised to power y is equals to 243, find the value of y. That is, we have to find the value of y that will make, that is, if we must have 3 here, raised to power something. So that will be 3 raised to power y is equals to 3 raised to power 5. 3, our main number is the same thing, it's just the power that we want to check. So our y is equals to 5. Example number 10. Simplify 9 raised to power minus 1 over 2 all divided by 27 raised to power 2 over 3.